You know that feeling, right? You spend hours getting a prompt absolutely perfect. Let's say you're working with GPT-4. You've got it completely dialed in, the output is flawless. And then you try to use that same beautiful prompt in Claude or Gemini, and it just breaks. It completely falls apart. It's not just frustrating, it's a massive waste of time and money for anyone building with AI.
So, let's get right into it. Why does this keep happening? Well, the heart of the problem is that every major AI model has its own little quirks, its own personality, if you will. They're all built on slightly different architectures, trained on different data mixes, and fine-tuned with different styles in mind. So, of course, a prompt that plays to one model's strengths might completely miss the mark with another.
And this right here, this is exactly what I'm talking about. On the left, you've got a prompt that just sings when you use it with GPT-4. On the right, that same exact prompt gives you absolute garbage on a different model, or it just ignores your instructions altogether. Now, this isn't just a small annoyance. If you're building an AI feature into a real product, this is a critical point of failure.
This leads us to what we call the prompt portability problem, and it's more than just a technical headache. It has some really serious real-world consequences, especially for anyone trying to use AI systems at scale.
This is where it really hits home from a business perspective. I mean, think about it. When your prompts are portable, you're not locked into a single provider, like OpenAI or Anthropic. You have freedom. You can instantly switch to a cheaper model to optimize your costs. You can build in reliability by having a fallback model ready to go if your primary one has an outage. And, this is huge, it allows you to actually test different models fairly to see which one performs best for a specific task, letting you use the best tool for the job every single time.
Okay, so how do we actually fix this? What's the secret? Well, we do it by focusing on universal design principles. The idea is to stop writing prompts for one model's specific quirks and start writing for the fundamental patterns that all of these models share.
And our goal, our North Star here, is what we call cross-model prompt compatibility. It's really the art and science of writing a single master prompt that just works, reliably, consistently, everywhere. It's portable and tough enough to handle those minor differences between the big players in the AI space.
So how do we get there? It really comes down to these 5 core principles. First, use universal language. That means no more saying using GPT-4's skills. Second, be incredibly explicit with your structure. Headers, numbered lists, make it super clear. Third, don't be afraid to repeat your most important instructions to build in some redundancy. Fourth, keep your formatting simple and universal. And finally, and this one is a game changer, include very clear error handling.
And here's the key insight. The reason this whole approach works. At the end of the day, despite their differences, all these models were trained on similar, massive chunks of the internet. They are all at their core instruction-following machines. They understand structure, they understand clarity, and they understand examples. By tapping into those shared patterns, we can pretty much sidestep their individual quirks.
All right, that's enough theory. Let's see this in action. We're going to look at a couple of concrete before and after examples that will make this crystal clear.
Okay, take a look at this. On the left, we have a pretty typical, kind of lazy prompt. It actually references a specific model and uses a vague word like concise. What does that even mean? But on the right, now that's a universal, powerful prompt. It assigns a clear role, you are an expert, it defines the task, and it lays out super explicit requirements in a numbered list, even giving a specific length constraint. So why does the good one work so much better? It's simple, really. By getting rid of that model-specific jargon and adding a clear role, a solid structure, and precise constraints, we've created a set of instructions that any major model can understand and execute. There's just no room for misinterpretation. It's unambiguous. Here's another really common one. Data extraction. The bad prompt on the left just says, extract the data. Use JSON format like GPT-4 does. It's making a ton of assumptions, right? It assumes the model knows what like GPT-4 does means, and it has absolutely zero error handling. But the good prompt on the right, it's a fortress. It defines the role, gives explicit instructions for what to do if a field is missing, and specifies the exact format it wants.
The big takeaway here is that by adding that explicit error handling and a precise format, you remove all the guesswork for the model. It doesn't have to guess what you want, and that's what makes the prompt so robust and portable. It ensures you get predictable, structured data every single time, no matter which model is doing the work.
Okay, so you've seen the principles, you've seen the examples. Now let's put it all together into a blueprint, a kind of toolkit that you can start using in your own projects right away. This is your step-by-step guide. First, just define the core task in plain English. Then, structure it with clear sections. Add very specific constraints on things like length and format. If you can, include a few-shot example. That's just showing the model a couple of examples of exactly what you want. And please, always test on at least 2 different models. Finally, add those fallback instructions for any edge cases.
And here you have it. This is a battle-tested template that you can literally copy and paste. Define the role and the task. List out your specific requirements, specify the exact output format you need, and define your error handling rules. This structure right here is the key to getting prompts that are both portable and incredibly reliable.
So, let's wrap this up. If you remember nothing else, remember these 4 things. First, strip out all model-specific language. Second, structure everything explicitly. Think in roles, requirements, and formats. Third, always plan for failure by including error handling. And fourth, never just assume your prompt is compatible. You have to test. Look, building prompts this way isn't just about getting slightly better outputs. It's about engineering more robust, more flexible, and more cost-effective AI systems. It's a fundamental shift from just optimizing for one model to building for an entire ecosystem. So the real question I want to leave you with is this: what prompt in your workflow is holding you hostage to a single model, and how are you going to make it universal?